Let's talk a little bit about oblique, or otherwise called slant asymptote. When do we have an oblique, O-B-L-I-Q-U-E, asymptote? It occurs when the degree of the top is greater than the degree of the bottom. Now, I'm not guaranteeing it's going to happen, but when you do have the degree of the top greater than the degree of the bottom, you should always check to see if you have an oblique asymptote. Now, what I want to do is show you an example of finding an oblique asymptote. Example. Here we have y equals a rational function, x squared minus 1 over x. So you see the degree of the top. The top is degree 2, but the bottom is degree 1. So do you see how the degree of the top is greater than the degree of the bottom? So let's find the slant asymptote. Slant, or oblique asymptote, is, you're going to do long division. You're going to divide the top, x squared minus 1, by the bottom, x, and then you're going to look at the answer. Okay, so x goes into x squared, x times x is x squared. Subtract. That's 0. Bring down the minus 1. And that's your remainder. You're going to bring it upstairs. Bring it upstairs. So you're going to have minus 1 over the denominator x. So we did this long division. We got our answer on the top. That implies that y equals the x, the top, the actual result of doing the long division, minus 1 over x. No, you don't include that. Exclude the remainder. It's just y equals x is our oblique asymptote. Let's try another example. We have y equals, let's see what we have here. We have negative x squared plus x plus 1 over x plus 1. Let's do the long division. Negative x squared plus x plus 1 divided by x plus 1. Okay, so what do we multiply x by to get negative x squared? We multiply it by negative x. Now distribute the multiplication. Negative x times negative x is negative x squared. Then a negative x times positive 1 is negative x. Put parentheses around that and subtract. Negative x squared minus a minus x squared is plus x squared. That's 0. Then we have x minus a minus is plus x. That gives us 2x because of the double negative. And then 1 minus nothing is a positive 1. Now ask yourself, what must we multiply this x by to get 2x plus 1? That's positive 2. So distribute the multiplication, and we get 2 times x is 2x. 2 times positive 1 is positive 2. Parenthesis, subtract. That leaves 1 minus 2 is negative 1. That's going to be our remainder. Our remainder is minus 1 over x plus 1. But we're not interested in the remainder. We're only interested in the portion that doesn't have the remainder. So the result is that our slant asymptote is y equals the negative x plus 2. So in both cases, you see the pattern is when the degree of the top of a rational function is larger than the degree of the bottom, do long division, the top divided by the bottom, ignore the remainder, and then write the answer. The equation of the slant asymptote, the oblique asymptote, is y equals the result of the division, ignoring the remainder. We have y equals